I'm Saskia, happy to have you join in. Many words have been written to describe or prescribe qualities that should be valued in theories and models. But the empirical literature is surprisingly silent on the subject. It tends to mention only the extent to which the model matches the data, and sometimes also its simplicity, but that's about it. But there's much more to consider. My PhD project aims to identify and make explicit the wider range of qualities that play a role in computational modeling in cognitive neuroscience. My intentions are to learn how design choices are related to the goals in particular modeling projects, to deepen our understanding of computational models, and to enable and encourage interdisciplinary work by providing a shared language for evaluating models across disciplinary traditions. I have taken qualitative interviews with leading researchers in the field to talk about their design choices, and I'm also running a quantitative study, a survey, and if you'd like to participate, please follow the link that will appear. In this flash talk, I'll briefly introduce 5 of the qualities that seem particularly pertinent. During the conference session, I'm opening the floor to discuss what we should understand by the various qualities, what you value in your research of the qualities we discussed here or other qualities, and what we should value in the field overall. First, empirical adequacy. A model is empirically adequate if it quantitatively matches the data to a satisfactory degree. But should it just be better than the alternatives or higher than a certain criterion? Now, of course, we want our models to fit to the data, but that by itself is a rather low bar, especially considering that the scope of most models is rather limited. So let's take empirical adequacy as a necessary but not a sufficient condition for a model to be considered an explanation of a certain phenomenon, and discuss other things we might desire. Simplicity is a frequently encountered argument to favor a certain model over another. However, simplicity definitions abound. Is simplicity best achieved by reducing the number of parameters or assumptions, or the number of components or causal factors invoked in explaining the phenomenon of interest? Or is it best achieved by reducing the scope of the model, or by making it easier to understand? Simplicity isn't really very simple. One thing we can say is that simplicity is an intentional distortion of the target phenomenon. Should it eventually be unpacked at different levels or in more elaborate models as we come to know more, or should we keep it for the ease of understanding that it provides? A competitor of simplicity is complexity or completeness. This is often pursued in the context of mechanistic explanations, where the more complete models contain more of the features that are relevant for the production of the phenomenon. One reason to pursue completeness is to increase empirical adequacy. Each added feature that is relevant to the production of a phenomenon comes with a new set of empirical hypotheses, which may or may not be verified by empirical testing. Increasing the degree of completeness is also likely to affect the ease of understanding, usually by reducing it. If our goal is to gain understanding, is this the right way to go? So what is this ease of understanding? It is related to the notions of cognitive salience and intelligibility, and many definitions have been proposed, all more or less explicitly related to the skills of the person or people considering a model. One can define it as the ease with which the reasoning behind an explanation can be followed, and how easily the implications and the scope can be evaluated, how easy it is to identify possible defeaters and caveats. One can also say that a scientific theory is intelligible to a subject in a given context if they can recognize qualitatively characteristic consequences of the theory without performing exact calculations. So just by looking at it, without performing any running of the model, you can see what is going to come out of it. Given that most people would identify explanation as the most important goal in science, should this not be the most important quality? And is it problematic that the quality depends on the skills of the evaluator and can be judged differently between groups of scientists over time and with different levels of expertise? This brings me to the final quality of discussion here, biological plausibility. The point here is usually that the architecture of the model is constrained by biological findings about process and structure. So the model assumptions are supported by empirical evidence, and this entails both the presence of relevant features as well as the absence of assumptions not in agreement with biology. An issue with biological plausibility is that, despite seeming to allow for an easy objective evaluation, there are different levels that can be called upon. So a skeptic might say that biological plausibility really is just fitting the data one values. These are some of the qualities that I'm investigating. Feel free to get in touch if you're interested, and I hope to see you at the conference to discuss these or other qualities.